Hello all. Today we will be discussing about n queen algorithm using backtracking method. Okay. So what it means, we are going to solve we are going to place n queen in a given matrix without each queen nullifying their powers. Okay, that is the challenge we are going to attack. What is the strategy we are going to use? This is a backtracking method. Backtracking means there is a bounding condition which allows your problems to leverage only possible very limited traversal. It means that any traverse, as you traverse, your conditions are violated, then you will not explore your traversal further and you will stop and you will move on to the next possible solution. If those conditions are not part of your assumption or your problem solving, you will end up in traversing more number of times and your time complexity and everything will increase. That is the whole idea of bringing the bounding conditions. So those functions we call them as bounding functions, right? Bounding functions. Okay, so for n queen problem solving, what are the possible bounding condition? The power of a queen, we know they cannot stand on the same row and no same column and no same diagonal, or when you mean diagonal you cannot place the queens in each diagonal. So now for a problem solving purpose we are taking 4 cross 4 matrix. Okay, so I'm trying to place 4 queens on top of it. So first column, second column, third column, fourth column, first row, second row, third row, fourth row, and the possible solutions I may get, I will put it here in the box. The column numbers I will write for queen 1, queen 2, queen 3 and queen 4. Okay, how much ever solutions I get. There can be a number of more than one solution also. For backtracking, we'll try to get all possible solutions. Let's keep traversing. First, we will place your Q1, okay, in the column 1. Okay, I'm going to write all the columns here. So Q1 in this cell, which allows this, I cannot place this, I cannot place because diagonal. So I'll place Q2 here. So Q2 in the column 3. So X2 in column 3. Correct. Next to column 3, what happens? Your 3 you cannot place it here, you can place them. If you place them, it's a diagonal. So placing Q3, okay, placing Q3 in the X is a violation of your bounding condition, so you will not do that. So placing your X3 again in the fourth position also is a wrong bounding condition, so you will not place them. So this is nothing but which leaves your Q3 no place. Correct. Placing Q2 in 3 is not giving any place to Q3. So move back and see whether you have any other option for Q2. Yes, we do have. So remove Q2 from here and place it here. So if you place, that is, go one step above, place X2 in the place of 4. Correct. In the place of 4, which allows you to place your X3 in the place of 2. So if you place it in 2, which allows your, if you are placing it here, which will not give any place for Q4, so that is bomb. This is also not allowing Q4 to finish. So go back and see Q3 can be placed anywhere. Q3 is no place because that's a final option. Q2 final option. Then move back to Q1 and see Q1 can be placed anywhere. So try to place Q1 in Q2. So now your Q1 is placed in Q2. We'll see how it looks like. Okay, 4 places, correct? So Q1 in your second position. So go back here and start your X1 in the second position. X1 in the second, and then Q2 in 4, X2 in 4, and then here your Q3, that is X3 in 1, correct, and then your X4 in 3. Wow, this gives you a solution. What is the solution? You placed all the Qs successfully. So Q1 in 2, Q3 q2 in 3, q3 in 1, q4 in 3, because these are all column numbers. 1, 2, 3, 4, those are all the columns. Okay, so keep traversing like this. Now move q1, go one step back. So try to see if we can place q3 anywhere. q3 no place. This is no. So go back and see q2 can be placed anywhere. No. So this is the only option. Then go back and see q1 can be placed anywhere. So q1 can be placed to x3. So let's start traversing. Here no place, so I'm writing here. See if q3 can be placed it here. So q3 means again I will draw here another box. q1 in third position, which gives you q2 in the first position. Then you can't place here, then q3 here, then you can't place here, you can't place here. So this is nothing but another solution, correct? So how to bring them? This is a root, so I am saying this is a root. Hope you can see that. The root from root x1 into third position, and then x2 in first position, x2 in your first position, and then x3 in your fourth position, then x4 in your second position. So x1, again another solution, write down here 3, 1, 4, 2. Okay, so these are all the possible two solutions.